For a cycle detection, we usually use Floyd's cycle finding algorithm. First, what is meant by a cycle? In a linked list, if one node points to a previous node, any previous node, then that's considered to be a cycle, right? In this linked list, 6 is pointing to 3, which is a previous node. It's not pointing to some forward node which has not been traversed or seen yet. So this linked list has a loop, and Floyd's cycle finding algorithm detects a loop which is actually it's not. Let me check. It's not a true information which detects a loop. Okay, and this technique is faster than if you just use a unique if you just use a hash map and then store each node, and if you see at some time a node is repeated, then you can tell that there is a loop. That means if you see a node which has been stored before, then the linked list has a loop. But the point is, this is not faster because you have to traverse the full list. In Floyd's technique, what we do, use 2 pointers. One is slow and one is fast. If one pointer meets the other pointer, then a loop is detected. Okay. If there's no loop, the pointers will never meet. We will see what we mean by this. The time complexity is O(n) because again we have to traverse all the nodes, but the space complexity is O(1) because we are not using any hash map or any other structure to store our nodes, right? So this algorithm is efficient space-wise. O(1) space complexity. Let's see how we can implement this. We will again define this method within the class, and we will name it, suppose, detect loop Floyd self. We need self, right? We will define a slow pointer and assign it self head. We will define a fast pointer. Again, we'll assign it head. While slow pointer is not equal to none, okay, and fast pointer is not equal to none, and first pointer dot next not equal to none, which means we will take into account the slow pointer, the fast pointer, and also the next of first pointer, because our first pointer will move fast. Whenever it will move by next dot next, which is why we need to know whether this is not none. If it is none, then we will enter to an infinite loop. So this is a main condition which you need to take into account. Okay, it's the moving condition. If algorithm says if slow pointer meets fast pointer, which means if slow pointer equal fast pointer, then we will say return true, which means a loop is detected. Else what we'll do, else we will move slow pointer by one step, assign slow pointer dot next, and then we will move fast pointer by two step, fast pointer dot next, which is why we needed to know whether this is not none. Okay, so this is move by one step and this is move by two steps, and there ends our function. It's really simple. We will have to write a code snippet which is which will initialize a loop, which will initialize or which will initialize a loop, a linked list with loop. Okay, here we will name this ll2. Okay, is equal linked. This is another linked list, not the previous one. Previous one was only ll, or we can name it ll loop since it will have a loop. We'll first initialize the head as 20 and then ll loop dot append for ll, suppose you can add anything, 15, and then ll loop dot append 10, and then first see whether we can display it. Okay, then we will create a loop. So the list will be 20, 4, 15, and 10. Yes. 10, 15, 4, 20. What happened? It has happened in reverse order. Why? And this is because we have actually made this one active. So we actually inserted at head, but we want this one active, right? Let's comment this out. Now hopefully it will work. Yes, it has worked now. Not inserting at head right now. Now we will write a loop. We will actually insert a loop. Create a loop in ll loop. Okay, how? So if you say that ll loop dot head dot next dot next dot next dot next is equal ll loop dot head okay. So in this case our ll loop has a cycle now because it's the next is 4, then the next is 15, then the next is 10, then again 10 is pointing to head 20. Okay, so you can create a loop anyhow you want and check whether our loop can detect it. Okay, I'll just call it if ll loop dot detect loop Floyd. If it returns a true, then print yes loop. Else print no loop. Run it. Yes loop. Yay! So it can detect the loop now. So as we all know that Floyd, this algorithm has only O1 space complexity, but normally if you don't care about space complexity and if you use method which will use a hash map to take care of all the nodes and see which one has been duplicated, then this you can use this function detect loop. First we will create a set, empty set S, and current node, assign current head node to current node while current node is not none. Remember, when we will insert something, if we use just current node, then use a while loop like this, we might lose all the linked list information because we will reach the last one's next node, which is none node. But here we are not going to insert anything. Okay, if current node is already in set, okay, in S, then return true, means yes, there is a loop. Okay, this is the condition. Else or if this true if is not executed, then which means it is not seen in the set yet, you have to add it to the set. You just have to add to insert in a set. Okay, and just move forward with your while loop. Current node assign current node dot next. And this is simple, has on time complexity and also has on space complexity because we are storing all the nodes in a set. And if this while loop is executed and nothing is returned, then return false. Let's check whether our indentation is right. Let's check if we use just detect loop without Floyd. Can it detect the loop? I have to run all the things. I don't know why this one doesn't work. I don't know. Yes. So without Floyd, it also is detecting loop, but Floyd is the faster. And this detect loop is a common question in it's a very common question if for linked list. If you face a linked list problem, then it's very common in both in HackerRank and also in LeetCode. Okay.